All right, we need to talk a little bit about isotopes. Isotopes are, they are in reference to atoms of the same element that have different masses. And those different masses are due to different numbers of neutrons. Okay, so anytime you see isotopes, you need to remember that it's the number of neutrons that is different. The number of protons must always stay the same because that identifies the atom or the element. So if you have fluorine, which is number 9, it will always, any atom that has 9 protons will be fluorine, no matter what. It doesn't matter how many neutrons, it doesn't matter how many electrons. If it has 9 protons, it is fluorine. If it has 20 protons, it is calcium, no matter what. Calcium can have different charges based on the different number of electrons, and it can have different isotopes based on different number of neutrons. However, it will always have 20 protons. Carbon, and you may have actually heard of several different isotopes of carbon. So carbon 12 is the most common. So when you see this 12, this is the mass number. And when you see a mass number, you need to remember that it is the number of protons plus the number of neutrons. So if you look at the periodic table, carbon actually has 6 protons. Always. Every carbon atom always has 6 protons. So carbon 12 has 6 neutrons as well. Okay, well, there's also something called carbon 13. It also has 6 protons, but its mass number is 13. So if it has 6 protons, then it must have 7 neutrons. 7 plus 6 equals 13. There's also another isotope of carbon called carbon 14, which I'm hoping that you get the trend here. It has 8 neutrons. Okay, so now carbon 14 is an isotope of carbon. It has a different mass of the atom because of the number of neutrons. The number of protons does not change. Okay, again, the number of protons does not change. Neutrons can, electrons can, but that's not isotopes, that's ions. So anytime you see isotopes, it's changing the number of neutrons. Okay. Now, depending on the question that you will be given, you will need to determine the number of protons, the number of electrons, the number of neutrons, the mass number. So if I simply gave you carbon, and I asked you for protons, neutrons, electrons, mass number, okay, you need to give me all of those. So to find the number of protons, again, you really just look at the atomic number. And the atomic number for carbon is 6, so that means it has 6 protons. This is a neutral atom, so it also must have 6 electrons. Okay. Now, I didn't tell you what isotope it was. Okay, so let me give you this information. I'm telling you it's isotope number 13, or it's carbon 13. That means that 13 is the mass number. So it has a 13 mass number. And from that, you can determine the number of neutrons being 7. Let's look at another example, helium. If I tell you that I have helium-3, okay, and now you have to give me the number of protons, neutrons, and electrons in addition to the mass number of helium-3. All right, well, the 3 tells me the mass number. So it has 3. According to the periodic table, helium has 2 protons. That is always true, otherwise it's not helium. And since it's neutral, which it is, I haven't told you otherwise, then the number of electrons must also be 2. So in that case, you need to determine how many neutrons are present in this isotope. And in this particular isotope, you have to look at, okay, well, the mass number is 3. 3 minus P, the number of protons, 2, is going to be 1. And so you can actually look at this. Is 2 plus 1 equal to 3? Yes. The number of protons plus the number of neutrons is equal to the mass number. Let's do one final example with boron. Now I'm not going to tell you what the isotope is, what its mass number is, but I will give you some piece of information in order for you to find out the rest. Okay? Now, I will tell you that this boron has, let's say, 5 neutrons. Okay, you have to give me the number of protons, number of electrons, and the mass number. Keep in mind, protons are always found on the periodic table. This is the atomic number. Boron's atomic number is 5. That means it has 5 protons. And it is a neutral atom, therefore it also has 5 electrons. Keep in mind, to calculate the mass number, you do protons plus neutrons. So here's your protons plus neutrons. That means your mass number must be 10. And if I asked you, what is this isotope, it would be boron 10. Another way you might see this is 10 at the top with a B like this. Okay, and you do need to know this. In some cases, you might even see it with the 5 down here. That would be its atomic number, its mass number, and the symbol. For helium over here, helium with its atomic number 2 and its mass number 3. Carbon 13 would be carbon, 13 at the top, 6 at the bottom for its mass number. So be sure you are able to understand and explain what each of those symbols means and essentially define. Tell me, okay, this is helium, but what is so special about this helium? I know it has 2 protons, but it has 3 for its mass number, so tell me how many neutrons it has based on this. You would need to be able to tell me it has 1 neutron. Okay, so keep that in mind for tomorrow. Tomorrow we're going to look at how to determine the average atomic mass of an element based on all of the different isotopes that are present in nature.